Hello students, good morning and welcome to Gradeup, India's largest e-learning platform. Now today important session on what analog, complete revision with complete formula. So ready guys, everyone? 1 minute. Okay, so please like, share and subscribe the channel. Then we will start our session and that will be very important session for GATE 2021. Complete revision of analog in two parts. Part 1 11 to 1 p.m. then part 2 9:30 to 11:30 p.m. followed by important numericals on Gradeup app. Okay, so Muglian, how are you? Amruta, Kiran, please like and share. Very good morning. And now this is analog part 1 GATE electronics GATE 20 for that is for what 2021. So ready guys? Now this session will be very useful. Then first of all, what about the syllabus? So please go through it. And this is everything is fine, sound quality, picture quality, everything is fine. Okay. Ayan, thank you for the feedback. Kirti, good morning, very good morning. Now and please tell me what is the role of analog for electronics, electrical and instrumentation branch. Yes, everyone. Before that, that is a network and that is one of the important topic. Then again what analog, बहुत ही अच्छी जुगलबंदी है between analog and what network. पूरा analog depend है network पर. And waveform synthesis, operational amplifier and then what complete syllabus. Okay. To start guys, now give me 1 minute. That is what is the syllabus here, that is diode circuit and then what rectifiers, filters, clipper, clamper and many more. Please go through the syllabus, everyone please go through the syllabus and give me 1 minute. Some technical issues. Okay. Now everything is fine. Sound quality, picture quality, everything is fine. But which topic is more important? Yes, everyone. Number of topics are here. Sorry for dismissal. Good morning, Vignesh. How are you? Sushma Kumar, Mamta, Akash, Bhargav, Kirti. Now, one by one, the number of topics are here. Then, first of all, diode circuit. Rectifiers, filters, precision rectifier, clipper, clampers and what voltage regulators. Everyone, this topic is important for what electronics student, electrical student and what instrumentation branch. Definitely you will get the question. Which one is important? We have no idea, but rectifiers, half wave, full wave, bridge rectifiers, filters, mainly there are 4 filters, C filter, L filter, LC filter and what pi filter, but most important one is C filter. Most important one is what? C filter. Right? Then next one, precision rectifier. Complete derivation and complete formula for C filters means what? What is the ripple factor? What is the ripple voltage? What about the frequency, ripple frequency and everything. Right? Crest factor, form factor, ripple factor. Then precision rectifiers means by using operational amplifier. Then what? Clippers and what? Clampers. Positive clamper, negative clamper and simple, you will get the, mainly we are getting the question from what? 2 level clippers. Means in a particular circuit there will be a 2 diodes and what? Then they will ask question. Okay. Okay then. Next one, voltage regulator. Mainly voltage regulator means what? By using Zener diodes, by using Zener diode and BJT. Series voltage regulator, shunt voltage regulator and then what? By using BJT, operational amplifier and what? Zener diode. So this is again a very important topic. Only 2 formulas required. only two formula is required for what? Voltage regulator and complete circuit. Okay, and then you will get the command over this. तो एकदम बहुत ही बेसिक टॉपिक्स है. मैं आप लोगों को दो फॉर्मूला बस बताऊंगा वोल्टेज रेगुलेटर पर, और आप देखोगे कि आपकी कैसे कमांड होती है. पूरे क्वेश्चंस बन जाएंगे. इसलिए मैंने कहा कि पूरे मेरे एक्सपीरियंस का फायदा उठाइए और देखिएगा जरा कैसे बनाते हैं. देन ट्रांजिस्टर बाइसिंग एंड स्टेबलाइजेशन, करंट मिरर सर्किट. दिस इज इंपॉर्टेंट, अगेन इंपॉर्टेंट फॉर इलेक्ट्रॉनिक्स, इलेक्ट्रिकल एंड व्हाट? इंस्ट्रूमेंटेशन ब्रांच. इलेक्ट्रिकल वालों को लगता है ना कौन से टॉपिक इंपॉर्टेंट है सर, किस पे ज्यादा फोकस करना चाहिए. तो पहला डायोड सर्किट, दूसरा ये ट्रांजिस्टर बाइसिंग एंड व्हाट? स्टेबलाइजेशन, करंट मिरर सर्किट. देन व्हाट? वंशराज, हाउ आर यू? गुड मॉर्निंग. देवी, गुड मॉर्निंग, वेरी गुड मॉर्निंग. रूपल, नए स्टूडेंट है आज तो काफी. हाउ आर यू? तो काफी दिनों बाद कई लोग दिखाई दे रहे हैं. तो देखिए जरा, BJT at low frequency is important for electrical student. Very basic concept. Only very small signal model. It is important for electrical. Right? Now, high frequency analysis mainly questions for what? Electronics student. Definitely you will get the question from high frequency analysis. Right? Not so important for electrical student. Then multi-stage amplifier and differential amplifier. Differential amplifier means what? CMRR, common mode rejection ratio, AD and what? AC. This concept is used in case of what? Operational amplifier. Differential amplifier by using ideal operational amplifier. Then Ram, how are you? Good morning. Then please like, share and subscribe the channel. अब ये बहुत ही अच्छी सीरीज है, फॉर्मूला 1 सीरीज, कंप्लीट रिवीजन ऑफ एनालॉग फॉलोड बाय व्हाट? नंबर ऑफ न्यूमेरिकल्स ऑन ग्रेडअप ऐप. मैं आप लोगों को ऐसे कुछ हर टॉपिक से 3 से 4 न्यूमेरिकल ऐसे करवाने वाला हूं जिसके आने की प्रोबेबिलिटी बहुत ज्यादा है. उससे पहले एक बार आप फॉर्मूला रिवाइज कर लीजिए मेरे साथ पूरा, और फिर आप आइए ग्रेडअप ऐप इंस्टॉल कर लीजिए, मुझे फॉलो कीजिए. संजय राठी, मैं आपको पूरी सीरीज आपके साथ शेयर कर रहा हूं. 8 लेक्चर्स होने वाले हैं ऑन एनालॉग. पूरे न्यूमेरिकल जितने भी इंपॉर्टेंट न्यूमेरिकल्स है सब डिस्कस हो जाएंगे. तो लो एंड हाई फ्रीक्वेंसी एनालिसिस ऑफ एफईटी. नाउ this is important because these days MOSFET is more important than what? BJT. We can get the question on small signal model, large that is what? DC analysis, AC analysis. तो ये है feedback amplifier not mentioned in the syllabus of GATE. Not mentioned. वो कुछ बताया ही नहीं है, लेकिन फिर भी भरोसा नहीं है, तो इसीलिए हम थोड़ा सा आइडिया लेकर चलें कि पता नहीं कैसे क्वेश्चंस आ जाए. और विदाउट फीडबैक इट इज नॉट पॉसिबल टू सॉल्व क्वेश्चन. राइट? तो डायरेक्ट शॉर्ट ट्रिक्स जो होती है वो फीडबैक एम्पलीफायर पर आती है. देन व्हाट? ऑसिलेटर्स. इट इज इंपॉर्टेंट. इट इज अ साइनसॉइडल ऑसिलेटर. पावर एम्पलीफायर इज नॉट मेंशन इन गेट. राइट? बट व्हाट इज द क्लास ए, क्लास बी amplifiers? What is the difference between what? Class A and Class B amplifier with formula what? Efficiency. More than sufficient. Now it is the most important one is what? Operational amplifier. Waveform generator means what? What is a waveform generator? Multi-vibrators. Multi-vibrators means what? Bistable, monostable, astable multi-vibrator. Symmetric trigger is a bistable multi-vibrator. And what? 5 important figures on symmetric triggers. 5 important. Only 5 figures. Important figures. एक भी क्वेश्चन उससे बाहर नहीं जाएगा. सभी क्वेश्चंस उसी 5 डायग्राम से आएंगे. विदिन 5 डायग्राम्स. ओके. देन वेवफॉर्म जनरेटर, रिलैक्सेशन ऑसिलेटर, दैट इज व्हाट? स्क्वायर वेव जनरेटर और स्टेबल मल्टी वाइब्रेटर. ओनली 2 to 3 डायग्राम्स, मोर देन सफिशिएंट. मोनोस्टेबल मल्टी वाइब्रेटर इज जस्ट लाइक अ छुपा रुस्तम. अभी तक मोनोस्टेबल मल्टी वाइब्रेटर से बहुत ही कम क्वेश्चंस आए हैं. वो डायरेक्ट आ सकता है बाय यूजिंग ऑपरेशनल एम्पलीफायर. रेडी रहिए गाइस उसके लिए, क्योंकि आपको बाकी क्वेश्चंस तो मिल जाएंगे अस्टेबल पे और व्हाट? सिमेट्री ट्रिगर पर. मोनोस्टेबल पर ज्यादा क्वेश्चंस आपको दिखाई नहीं देंगे. तो मोनोस्टेबल बन सकता है एक छुपा रुस्तम. तो ये देखिएगा. लीनियर वेव शेपिंग सर्किट, ये तो इंपॉर्टेंट है नेटवर्क के लिए भी, एनालॉग के लिए भी. पल्स रेस्पॉन्स ऑफ हाई पास आरसी एंड व्हाट? लो पास आरसी सर्किट. एवरीथिंग अबाउट व्हाट? हाई पास एंड लो पास आरसी सर्किट. एंड दैट इज व्हाट? सिंपल सिलेबस ऑफ एनालॉग. राइट नाउ, तो क्या ये ओवर हो गया, खत्म हो गया कि जस्ट स्टार्ट होगा? ऐसा ही होता है ना, सिलेबस देखने के बाद लगता है कि अब हो गया सब कुछ. नो, यहां से हमारी जर्नी स्टार्ट होगी एनालॉग की. राइट? और मैं आप लोगों को रिवाइज करवाने वाला हूं कंप्लीट फॉर्मूला. तो फटाफट लाइक कर लो, शेयर कर लो. ये आपके सामने जो शेड्यूल है ना, ये देख लीजिए जरा एक बार प्लीज. ये पूरा स्क्रीन मैं आपके साथ YouTube चैनल पे आपके साथ शेयर करूंगा. और ये देखिए अभी तक के ओनली 30 वॉचिंग है. प्लीज लाइक एंड शेयर ओके, हाँ, अब आप एक बार इसके थ्रू जाइए और आपको पता चलेगा कि क्या हो रहा है यहां पर। यस एवरीवन, देखिए जरा, ये जो मैंने जो आपको ये दिया है ना, ये सीरीज, 1 मिनट, जरा आपकी कमेंट्स भी देख लीजिए। ओके, गुड मॉर्निंग Sri Vanilla, how are you? Now, this is a complete series. Analog, operational amplifier, tricky questions on differential amplifier, Sanjay Rathi, and then I will upload this complete series on Telegram channel. Please join our Telegram channel. The description is given below. Okay? तो ये सब कुछ अवेलेबल होने वाला है आप लोगों को। Then, देखिए टॉपिक्स देख लीजिए, ऑन डिफरेंशियल एम्पलीफायर, देन व्हाट इंटीग्रेटर एंड डिफरेंशिएटर, सैलन की एंड बटरवर्थ फिल्टर्स, दिस इज अ न्यू टॉपिक, मोस्ट प्रोबेबल टॉपिक्स, राइट, सैलन की एंड बटरवर्थ फिल्टर, 5 डिफरेंट टाइप्स ऑफ सिमेट्री ट्रिगर, देन व्हाट रिलैक्सेशन ऑसिलेटर, एवरीथिंग अबाउट रेक्टिफायर्स एंड फिल्टर्स, क्लीपर एंड क्लैंपर, ट्रिक टू सॉल्व क्वेश्चन विद इन 60 seconds, हाउ वी कैन सॉल्व द 60 seconds, point to point description of biasing techniques and cell bias circuit, right, and that is the schedule up to what 31st January, then 1st of Feb। ये आप लोगों के लिए बहुत ही ज्यादा यूजफुल होने वाला है, कोई आपको एक्स्ट्रा रिवीजन करने की जरूरत नहीं है। यस, ये सभी पीडीएफ आपको प्रोवाइड होगी पूरे फॉर्मूले के साथ। तो इट इज माय स्मॉल इंट्रोडक्शन फॉर न्यू स्टूडेंट, माई सेल्फ संजय राठी, इसीलिए मैंने पहले एनालॉग के बारे में बताया, उसके बाद मेरा इंट्रोडक्शन है। दैट इज माई, आई एम हैविंग 19 years of teaching experience and I have qualified engineering services exam 3 times in electronics and telecommunication branch। उसमें एनालॉग ने सबसे इंपॉर्टेंट रोल प्ले किया है, ध्यान रखिएगा, ठीक है ना। तो आई हैव मेंटर्ड मोर देन 1 लाख स्टूडेंट्स फॉर दिस एग्जाम्स, और मुझे पता है कि सब्जेक्ट में कैसे कमांड की जाती है, कौन कौन से टॉपिक्स इंपॉर्टेंट है। ये इसलिए है ताकि आपको कॉन्फिडेंस आए कि आप सही हाथों में हैं, सही जगह पर हैं और सही इंसान से पढ़ रहे हैं आप। ओके, और आप सही प्लेटफॉर्म पर हैं, दैट इज अ ग्रेडअप, India's largest e-learning platform. Then 3 courses, Gear Up, Rank Up, and what? Vision 2022. For more detail, you can call us or you can write us on our mail ID. Then this is a faculty member, highly qualified and highly experienced faculty members for electronics and electrical group here. Okay? तो ये है rankers. Try to get the single digit rank, that is under 10. Okay? हालांकि अगर 100 है तो भी बेटर है, और फर्स्ट रैंक लाने की कोशिश करनी चाहिए सभी को बिना किसी डर के। तो देखते हैं जरा। यस, सुषमा कुमार, आई विल अपलोड द पीडीएफ, जस्ट ऑलरेडी ऑल द पीडीएफ्स आर अवेलेबल। दिस इज अबाउट ग्रेडअप सुपर, इट इज अ सब्सक्रिप्शन बेस्ड मॉडल, इन वन सब्सक्रिप्शन अनलिमिटेड एक्सेस टू ऑल द कोर्सेज। फॉर मोर डिटेल यू कैन कॉल अस, राइट, एंड दैट इज अ फी स्ट्रक्चर। नाउ वी विल स्टार्ट विद व्हाट? ऑपरेशनल एम्पलीफायर। Why operational amplifier? Because each and every device based on operational amplifier. Then what will be the sequence? Complete revision of operational amplifier, waveform generator, that is what timing is what 11 to 1 p.m. and then 9:30 to 11:30 p.m. evening, today itself, complete revision of remaining topics. It is a formula series. Directly I will give you the formula and important points about the circuit, and then we will solve numericals on Gradeup app. Okay, then let's start. Now what is operational amplifier? Operational amplifier is basically a voltage amplifier. It is a voltage controlled voltage source. Is it clear? The input resistance of the operational amplifier is very high, the output resistance is very low, right? The gain of the operational amplifier, it should be ideally infinite. The gain bandwidth product is called figure of merit. So figure of merit, right? Why it is called operational amplifier? Why it is called operational amplifier? Because basically it is invented to execute mathematical operation, and that's why it is called operational amplifier. Yes, Pragya, how are you? Sir, analog PDF नहीं था भी रैपिड सीरीज समझ आएगी? अच्छा, आपने नहीं पढ़ा है तो भी रैपिड सीरीज समझ आएगी। ये दैट इज व्हाट फॉर्मूला बेस्ड, एंड देन आई विल गिव यू द फॉर्मूला, एंड देन इट इज फॉलोड बाय व्हाट? न्यूमेरिकल्स। ग्रेडअप ऐप पर आप आइएगा, वहां बहुत सारे न्यूमेरिकल सॉल्व करने वाले हैं। पहले एक बार पूरा ओवरव्यू ले लो एनालॉग का, आ जाएगा आपको समझ में, कोई घबराने वाली बात नहीं है, ठीक है। तो बस कंटिन्यू करते रहिए। नाउ एक कम से कम एक ओवरव्यू तो मिल जाएगा कि आपको क्या पढ़ना है और क्या क्या नहीं पढ़ना है, ठीक है ना। तो वोल्टेज गेन infinite, directly they will ask the question on what characteristics. Normally it is a 10 to the power 6. Input resistance infinity, normally it is a 10 to the power 6 ohm or 1 mega ohm. Output resistance 10 to 100 ohm. Then what? Gain bandwidth product. Gain bandwidth product. This is called figure of merit. Always, everyone. Figure of merit for what? Any amplifier. Gain bandwidth product. Ideally it should be infinite. Practically it is 10 to the power 6 hertz. Bandwidth is infinity. Ideally we want the bandwidth should be infinite, but it is 10 to the power 6 hertz. If after negative feedback gain reduces to 1, then gain bandwidth will become what? 10 to the power 6 hertz. And that is the beauty of what? Operational amplifier. Operational amplifier is basically a multi-stage amplifier. Why we are providing the multi-stage? Everyone give me the answer. What is the basic purpose of multi-staging? What is the basic purpose of multi-staging? Everyone give me the answer. What is the basic purpose of multi-staging? Yes. Right. तो बताइए जरा क्या है मल्टी स्टेजिंग का बेसिक पर्पस? यस. Now, operational amplifier is basically a multi-stage amplifier, right? Now, the first stage of operational amplifier is differential amplifier. We are having the two terminal. One is what? Inverting terminal. One is what? Non-inverting terminal. Why the first stage is differential amplifier? Again, okay. No, Vignesh. At this time they will ask you the MSQ, multiple selection question. MSQ, multiple selection question. It is a multi-stage not to improve the gain. Always remember the basic purpose of multi-staging is to improve the gain bandwidth product. It is not to increase the gain. Gain bandwidth product. What is the gain of operational amplifier? What is the gain of? Everyone give me the answer for the question. It is, you will get the MSQ. Always remember what is the gain of the operational amplifier, inverting operational amplifier. The inverting operational amplifier is what? What is the gain? Minus RF by R1, that is minus 10. What is the gain of the non-inverting operational amplifier? 1 plus RF by R1, that is 11. Only 11. Right? 1 plus RF by R1, that is what? 11. Then the gain is very small. Then why we are providing the multi-staging? To increase gain bandwidth product. Okay? Gain bandwidth product. Now, basically operational amplifier. Now, second one, why the first stage of operational amplifier is a differential amplifier? Reason, simple reason, it is a direct coupled amplifier. Operational amplifier is a direct coupled amplifier. It can amplify DC signal as well as AC signal. And direct coupled amplifier suffers from drift problem. To remove this drift problem, we are using differential amplifier. And that's why the first stage of operational amplifier is what? Differential amplifier. It is basically a differential amplifier. Okay. Second thing, the input resistance. Why we are using the emitter coupled differential amplifier, ECDA? Because its input resistance is too high. Ideal condition, the input resistance should be infinite. Okay, and that is CMRR, common mode rejection ratio. This is the figure of merit for differential amplifier. Operational amplifier is basically a differential amplifier. Ideally it should be infinite, practically it should be 120 dB. Slew rate, this is again another characteristics of operational amplifier, that is called maximum rate of change of output voltage. Maximum rate of change of output voltage, or simply the rate of change of output voltage when large signal is applied. Large signal is applied. dV0 by dt max. Every new students, always remember the unit of that is what? Volt per microsecond. Slew rate. Unit is what? Volt per microsecond. It is nothing but slope of output waveform. देखिए मैं जो पॉइंट्स बोल रहा हूं याद रखिएगा. स्लोप ऑफ आउटपुट वेवफॉर्म. अगर किसी क्वेश्चन में आपको बिल्कुल सिंपल सा दे दे स्लीव रेट निकाले तो आप क्या करेंगे? कुछ मत कीजिए. ये है आपका स्लीव रेट. फाइंड द स्लीव रेट ऑफ दिस आउटपुट वेवफॉर्म. Then simply it is a time. It is what? Slope. Find the slope of this line. Suppose it is a minus 10, it is a 20, and it is a 1 microsecond. It is a 0, it is a 4 microsecond. Right? Then please give me the slope. The slope is what? This is the 20, this is 10. So what is the change? 30 divided by 4. 30 divided by 4 volt per microsecond. That is nothing but slew rate. That is nothing but slew rate. Okay, my dear friends? Listen, slew rate is what? Maximum rate of change of output voltage. Again, you have to find the slope of this line. Out of these two, which one is more? Which one is more? Suppose we are getting the 2 rate of change of slope, that is another is what? Minus 25 by 4 volt per microsecond. Then the magnitude of first one is high, and that's why it is a slew rate. If the magnitude of second one is high, then it will be the slew rate. So what is the slew rate? Maximum rate of change of output voltage. Definitely I will provide you the more formula, but it is a very basic formula about the slew rate. Okay. Okay then. Right answer 7.5 Vignesh. Good one. तो आपको डायरेक्ट वेव फॉर्म देगा, डायरेक्ट निकाल लीजिए. The next one, symbol of operational amplifier, right? Most popularly used is IC741. Finished. Okay, it is a 8-pin IC. कोई आपसे ज्यादा आईसी के बारे में नहीं पूछेगा, लेकिन आपको पता होना चाहिए. It is a 8-pin IC. Normally this is called plus VSET and minus VSET. In case of 741, it is normally 15 volt and minus 15 volt, but we can arrange any value, 10, minus 10, right? In some question it is a 12, minus 12. They can ask any value. Then it is the internal diagram of the operational amplifier. Always remember, this is the V in, this is the GV in, this is G is nothing but gain, R out. Right? It is basically a voltage amplifier. For any voltage amplifier, the equivalent circuit will be like this. This is the normally it is the AVVI. This is the R naught. This is the RI, and this is what VI. For any voltage amplifier, the basic diagram is like this. Then here we are connecting the RL. Here we are connecting the RS. And VS. This is a simple internal diagram of voltage amplifier. क्यों जरूरी है, मैंने क्यों बताया ये बता दूं. कई बार क्या होता है, क्वेश्चन समझ नहीं आ रहा है, we are not getting the connections, then we have to follow the internal diagram. Always remember, if suppose we are not able to solve the question, some new information is there, then always draw the internal diagram of what? Operational amplifier. For example, in a particular question, RI is given, R0 is given, AV internal gain is given, right? Then how to solve? Simply draw the diagram and use the concept of what? Network, and definitely you will get the answer. Direct answer. कोई फॉर्मूला नहीं, कुछ नहीं, सीधा नेटवर्क लगाइए, क्वेश्चन सॉल्व. ओके, तो चलिए देखते हैं. अभी देखो यार, थोड़ा सा इसे लाइक कर लो, शेयर कर लो. काफी अभी सुबह मॉर्निंग सेशन में थोड़ा स्टूडेंट्स को पता होना चाहिए कि बहुत ही इंपॉर्टेंट सेशन चल रहा है. ये आप लोगों की ड्यूटी है. फटाफट थोड़ा सा IC741, दिस इज द 8-pin IC, कंप्लीट डिटेल्स. तो प्लीज गो थ्रू इट. आई विल प्रोवाइड यू द PDF, राइट? तो ये है, आप स्नैपशॉट भी ले सकते हैं इसका. ओके, दैट इज द 8-pin IC, IC741. The next one, what is the virtual short process? In a simply, the gain of the operational amplifier is infinite. The gain is infinite, means simply virtual short. V positive is equal to V negative when there is a negative feedback. Always remember, when there is negative feedback, virtual short concept is valid. In case of positive feedback, virtual short concept is not valid. In case of negative feedback, virtual short concept is valid, but in case of positive feedback, virtual short concept is not valid. Okay? Now, operational amplifier is completely divided into two parts. Op-amp with negative feedback and op-amp with positive feedback. Okay? Op-amp with negative feedback means what? Inverting op-amp, non-inverting op-amp, differential amplifier, voltage to current converter, current to voltage converter, integrator, differentiator, logarithmic amplifier, anti-logarithmic amplifier, right? All filters, Salinki filters, Butterworth filters, first order, second order, all pass filter, notch filters. In every case, there will be a negative feedback. What about the positive feedback? Positive feedback means what? Bistable multivibrator, monostable, astable multivibrator, symmetric trigger, square wave generator, triangular wave generator, right? तो इन सब डायग्राम में होगा नेगेटिव पॉजिटिव फीडबैक और यहां है सब नेगेटिव फीडबैक. And that's why operational amplifier is divided into two parts, amplifiers and what? Waveform generators. Waveform generators. Is there is any doubt up to this point? So you can ask me the doubt. So simply we are using the virtual ground process or virtual short process. Virtual ground is nothing but a special case of what? Virtual short process. Why we are providing the virtual short or virtual ground? Because the gain, normally the gain of the operational amplifier is what? Infinity. Right? To infinity, then the voltage between these two terminals, the voltage difference between these two terminals is negligible, Vi, to provide V0, and that's why this we are taking V0, Vi is equal to 0, and then positive terminal voltage is exactly equal to what? Negative terminal voltage. Simple concept. Then, देखिए, op-amp with negative feedback and op-amp with positive feedback. If the closed loop gain is less than open loop gain, negative feedback. If closed loop gain is greater than open loop gain, then it is called what? Positive feedback. Okay. Now again, that is the list. Please take the snapshot. New students, and that is the complete series just after this Formula 1 series on a Gradeup app. And we will discuss important numericals on differential amplifier, integrator, Allen key, 5 different types of symmetry trigger, right? And then what? Relaxation oscillator, everything about the rectifiers and filters, clipper and clamper, point-to-point description of biasing techniques and cell bias circuit. No doubt, it is not possible to cover complete syllabus. इसीलिए हम लोग यहाँ पर क्या कवर कर रहे हैं? फॉर्मूला पूरा. और फिर यहाँ पर बनाएंगे only numericals. Only numericals. This series is dedicated for what? GATE 2021 only. GATE 2021. जिनकी कुछ भी प्रैक्टिस नहीं हुई ना, वो भी आ जाइए, पूरे क्वेश्चंस एनालॉग पूरा तैयार हो जाएगा. Electronics, electrical and what? Instrumentation branch. So rapid fire revision series on app by me, Chandan sir and Rakesh Talreja sir. तो अब देखते हैं जरा इन्वर्टिंग ऑपरेशनल एम्पलीफायर. चलिए फटाफट देखते हैं इन्वर्टिंग ऑपरेशनल एम्पलीफायर में कितने पॉइंट्स हमें पता होना चाहिए. कौन कौन से पॉइंट इंपॉर्टेंट है? फर्स्ट ऑफ ऑल, अंडर आइडियल कंडीशन द गेन इज गिवन बाय -RF/R1. सेकेंड, under practical condition gain is given by -AV beta upon 1 plus AV beta into RF/R1. Right? Now, what is the beta here? R1 upon RF. Sorry, R1 upon R1 plus RF. This is the R1 or Rin. If it is written Rin, normally it is represented by R1. So R1 upon R1 plus RF, it is the value of what? Beta, and that is a practical answer. Feedback mechanism, voltage shunt feedback. Voltage shunt feedback. Okay. In case of voltage shunt feedback, if suppose some student asks what about the input resistance? So input resistance for this amplifier, always remember the input resistance is given by the input resistance seen by this battery. Always remember the input resistance is nothing but R1. Under ideal condition, feedback mechanism is voltage shunt feedback, and that's why if suppose we want the input resistance up to this point, always remember input resistance up to this point. If the input resistance of the operational amplifier is given as, then RIF, that is called RIF, Ri upon 1 plus of beta Rm. It is a formula series, just I am revising the formula. Beta Rm, what is the Rm? Trans resistance, because it is a voltage shunt feedback. So this formula is important. Input resistance directly you can say like this, R1, and this is important. Okay. So this is everything about what? Inverting operational amplifier. Okay guys. तो यहीं से क्वेश्चन आएंगे, आपको डायरेक्ट फॉर्मूला याद रखना है. Voltage shunt feedback, both input and output resistance decreases. Both input and output resistance decreases. Next one, that is the exact solution. Now, non-inverting operational amplifier, which point is more important? This is a direct gain 1 plus RF/R1. What is the practical formula? Everyone give me the formula. Practical formula, that is AVS, this is called V0 by Vs. Normally it is represented by Vs or Vin, and this is a opposite diagram. Then it is given by AV upon 1 plus beta AV. right? What is the beta here? R1 upon R1 plus RF. R1 upon R1 plus RF or R2. Normally it is represented by RF. Now suppose we are getting this type of diagram, then please revert back and then you will get like this. Plus this is the Vs. ओके, दिस इज द डायग्राम एक्चुअली. तो कई बार क्या होगा, आपको ना फॉर्मूला पता नहीं होगा. देखिए कई बहुत सारे, ये तो स्टैंडर्ड डायग्राम है, कई बार डायग्राम समझ नहीं आता, जैसे उल्टा बना दिया, पता नहीं क्या बोलना चाह रहा है, क्योंकि नॉर्मली हमारी प्रैक्टिस है ऊपर नेगेटिव नीचे पॉजिटिव. तो पूरा डायग्राम को रिवर्स कर दीजिए, आपसे डायरेक्ट सॉल्यूशन बन जाएगा. ओके, तो ये भी एक ट्रिक है. अब याद रखिए एवी अपॉन 1 प्लस बीटा एवी, बीटा इज R1 अपॉन R1 प्लस RF. द फीडबैक मैकेनिज्म इज व्हाट? वोल्टेज सीरीज feedback. Feedback mechanism is voltage series feedback. If suppose the input resistance and output resistance is given, then always remember ideal condition, input resistance seen by the Vs is infinity. Infinity. The current enter into the operational amplifier is 0. Practical condition, always remember the practical condition, the input resistance seen by the Vs, this is called RIS, is given by the input resistance of the operational amplifier 1 plus beta AV, and the output resistance, because it is a voltage series feedback, the output resistance is given by ROS, or yahan this is the point, R0 upon 1 plus beta AV. R0 upon 1 plus beta AV, that is the actual formula for input resistance and output resistance. Okay, and always remember the bandwidth, overall bandwidth is given by the bandwidth of open loop operational amplifier multiplied with 1 plus beta AV. This is a new concept. Just always remember. After negative feedback, gain reduces but bandwidth increases, and the gain bandwidth product will remain constant. Right? So this is the gain reduces by 1 plus beta AV. This is AV is the open loop gain. 1 plus beta AV is called desensitivity factor. If the gain reduces by 1 plus beta AV, then the bandwidth will increase by 1 plus beta AV. Okay, that is the advantage of negative feedback. What is the feedback mechanism? Voltage series feedback. Okay, this is all about what? Non-inverting operational amplifier. This formula is very important. Please revise this formula. This is important. And this is most important one. Definitely you will get the question on this. Okay. Right guys, anything? Yes, there is another one question, error in calculation. Both in non-inverting and inverting, error in calculation. So always remember what is the meaning of error in calculation. Error, percentage error, means when we are giving the virtual short concept, it is an approximated analysis. And we are getting the answer. That is an approximated answer. For non-inverting, R minus RF by R1. For inverting, 1 plus RF by R1. This is what, it is not an exact one. It is an approximated one, AVS. AVS. What is the exact one? AVS is equal to minus AV beta upon 1 plus AV beta into RF by R1. What is the exact one for non-inverting? AVS is equal to AV upon 1 plus beta AV. What is the beta here? R1 upon R1 plus RF. So what is the error in calculation? Direct question on error in calculation for both, whether it is a non-inverting or inverting. 1 upon AV beta into 100%. 1 upon AV beta into 100%. Yes, this is called error. Okay, Banjari Mayur, how are you? And Vignesh, now, and please like and share the that session कि ज्यादा से ज्यादा लोग आए. और इसका देखो बहुत जबरदस्त बेनिफिट होने वाला है. पूरा अभी हाफ एन आवर तो हो गए, अब पूरा कंप्लीट रिवीजन होगा और इससे आपको आइडिया लग जाएगा कि कौन कौन से पॉइंट इंपॉर्टेंट है एनालॉग में. और अभी हम लोग करने वाले हैं बस ऑपरेशनल एम्पलीफायर एंड वेव फॉर्म जनरेटर, एंड देन इवनिंग 9:30 to 11:30 रिमेनिंग पोर्शन. ठीक है ना. और उसके बाद क्या होने वाला है, उसके बाद ग्रेडअप ऐप पर पूरी क्लासेस चलेंगी जहां मैं आपको इंपॉर्टेंट न्यूमेरिकल सॉल्व करवाऊंगा, लेकिन वो तभी आप समझ पाओगे जब इसको पूरा अटेंड कर लो, राइट, फटाफट। और आपको कोई एक्स्ट्रा रिवीजन करने की जरूरत नहीं पड़ेगी एनालॉग की, आपको कुछ नहीं पढ़ना, बस आप यहां पर अटेंड कीजिए, आपको पूरा कंप्लीट सिलेबस रिवाइज हो जाएगा। उसके बावजूद भी आपके पास टाइम है काफी, आप कर सकते हैं। ओके, देखिए, चलिए अब देखते हैं जरा। नाउ दिस इज व्हाट एरर। Always remember this result, the mod of this is what overestimated. Overestimated means if suppose the exact answer is from this, it is 10. Then what is the approximated answer for that? It will be 11. Approximated answer is what? 11. Means it is what? Overestimated. Always approximation is what? Overestimated. So in both the cases, the AVS is overestimated. Normally in case of analog, 99% during approximation, after calculation, the result will be what? Overestimated by some percent. It is overestimated, and that is the percentage error, 1 upon AV beta into 100. If we are increasing the gain, if we are increasing the beta, the percentage error will reduce. Okay. So now inverting summer, it is a very, very important, and always remember, in case of inverting op-amp and non-inverting op-amp, we are using the two condition, ideal condition and what? Practical condition. But when we are making inverting summer, non-inverting summer, integrator, differentiator, voltage to current converter, current to voltage converter, normally we are taking what? Ideal operational amplifier. Otherwise it is not possible to make. Okay, so it is an ideal operational amplifier, and in case of ideal operational amplifier means simply the gain, open loop gain is what? Infinity or very high, that is the 10 to the power 6. Now virtual short concept is always valid. In case of this, virtual short concept is valid, and directly because it is a linear integrated circuit, we can directly write the V out. Always remember, it is a linear integrated circuit, and that's why we can apply the superposition theorem. And according to superposition theorem, what will be the output? Minus Rf by R1, this is the R1, R2, R3, Rn. Directly you can write minus Rf by R1 into V1, minus Rf by R1 into V1, minus Rf by R2 into V2, minus Rf by R3 into V3, and so on, minus Rf by R1 into Vn. That is the simple value. That is called inverting summer. If all Rf and R1 are equal, Rn, then the V out will become minus V1 plus V2 plus V3 plus Vn. That with negative sign, 180 degree phase shift, that's why it is called what? Inverting summer. Okay. Sir, in numerical answer type questions, we have to use the actual formula. No, they will ask you, if suppose it is written as that, for example, it is ideal operational amplifier, then we have to use what? Approximate formula. If the gain is very high, that is 10 to the power 6, again use the approximate formula. But in a particular question, if the open loop gain is given as when this formula is applicable, when these two formula are applicable, everyone, Ram, good question. When this formula is applicable, suppose in a particular numerical, open loop gain is given as 200 or 300 or what 50 or what 45 or less than 1000. Normally less than 1000. When AV, open loop gain is given as less than 1000, then we have to use what? Exact one. This is the exact one. Otherwise we can use these two formula. When AV is more than 1000, because of this formula, the error is very small. Error, right? Otherwise we have to use the exact formula. Okay Ram, it is clear? Is it clear? कब use करना है, कब use नहीं करना है? When the gain is less than 1000, open loop gain of the operational amplifier. Otherwise nothing is given, you have to take AV is equal to what? Infinite. If AV is given as 10 to the power 6, again use what? Approximate formula. Don't worry about that. Okay. The next one. चलो देखें जरा कौन कौन क्लास भी अटेंड कर रहा है. अब देखते हैं डिफरेंशियल एम्पलीफायर. नाउ थर्ड वन इज व्हाट? differential amplifier. Differential amplifier means what? First is inverting amplifier, non-inverting operational amplifier, then what? Inverting summer. Now the differential amplifier. Differential amplifier means what? Ideal differential amplifier. It is a most important topic, most important one, right? So what is the differential amplifier? Ideally the differential amplifier V1 minus V2. It should be proportional to what? V1 minus V2. Now the V0 should be equal to what? AD VD. Means what is the VD? This is nothing but VD. V0 is proportional to VD. VD is the difference signal V1 minus V2. Ideal condition, right? But practically when we are making the differential amplifier, always we are using what? Some concept here. Just I am giving you the concept here, please. Right? Okay. Now, this is the one amplifier, another amplifier. What is the phase shift because of this 0 degree? What is the phase shift because of 180 degree? One is inverting, one is non-inverting, and then what? We are using the summer. This is the summer. And we are getting the output. The gain of this is A1, the gain of this is what? A2. Here we are giving the V1, here we are giving the V2. Then output is what? A1 V1, A2 V2, then A1 V1 plus what? A2 V2. The simple the gain of the differential amplifier. Now directly you can apply the A1. If A1 is exactly 10, A2 is equal to minus 10. What is the phase shift? 180 degree. Then output will be V0 is equal to 10 times of V1 minus V2. It means the mod of A1 should be exactly equal to mod of A2. Mod of A1 should be exactly equal to what? Mod of A2. Second thing, always remember. The phase shift of A1 is 0 degree and the phase shift of A2 is what? 180 degree. Then it is an ideal differential amplifier. Now everyone, but practically it is not possible to make A1 is equal to A2, and that's why we are facing the problem. So what is the practical formula? Practical formula for differential amplifier is V0 is equal to AD VD plus what? AC VC. So AD is what? Simply that AD, difference gain, and what? AC is what? Common mode gain. Always remember, if these are the two signals V1 and what? V2, then the difference is called VD, and the common mode signal, always remember common mode. कई लोगों को डाउट है कि सर कॉमन का मतलब क्या है? कॉमन मीन्स व्हाट? एवरेज वैल्यू इज व्हाट? VC V1 plus V2 by 2. This is called average or common value, and that is called difference. So this difference is VD by 2, this difference is VD by 2. Now sometimes they will ask question like this. Always remember, this is a very basic concept. Then what? VD is equal to V1 minus V2. This is the two signals. Then we can write V1 is equal to what? VC plus VD by 2, and V2 is called VC minus VD by 2. These are the two formula. And what is the formula? V0 is equal to A1 V1 plus what? A2 V2. Replaced by this, so we will get A1 VC plus VD by 2, A2 VC minus VD by 2, and then we can arrange V0 is equal to A1 minus A2 by 2 into VD plus A1 plus A2 into what? VC, and this is called AC, and this is called AD, and that is. In a particular question, they will give you the value A1 and A2, and you have to find what? We have to find AD and AC. Yes, AD and AC directly. So what is the formula here? Always remember this formula. AD is equal to A1 minus A2 by 2, AC is equal to A1 plus A2. Right? Under ideal condition, if A1 is equal to 10, A2 is equal to minus 10, then this AC will become 0. This is called ideal condition. And AD will become what? 10 of minus 10, this will become 10. And then output is directly V1 minus V2. It means ideally the AC should be equal to 0. Ideally AC should be 0. Practically it should be as small as possible. MSQ. Differential amplifier, definitely you will get the MSQ. MSQ. AC. Then CMRR, common mode rejection ratio. It is called figure of merit. This is nothing but mod of AD by mod of AC. Ideally AC should be 0, so CMRR should be what? Infinite. It is 0, so CMRR should be infinity for differential amplifier. Right? It is called figure of merit. What is the meaning of figure of merit? On the basis of which we can compare the two differential amplifier. If one differential amplifier has CMRR is 10 to the power 6 and another differential amplifier has CMRR 2, that is 100, then please tell me which one is better, first one or second one, everyone. Which one is better? Tell me. First CMRR 1, 10 to the power 6, CMRR 2, 100. Then which one is better? No. They will ask direct question on this CMRR. Second, what is the percentage error? Percentage error means what? What is the output? AD/VD plus AC/VC. This is error. This is wanted term. So what is the percentage error? Percentage error is nothing but AC/VC divided by AD/VD into 100%. This is the direct formula. AC by AD is nothing but 1 by CMRR. 1 by CMRR into VC by what? VD into 100%. VC, we are having the signal, common signal V1 plus V2 by 2. VD is equal to what? V1 minus V2. Yes. Kirti, Vignesh, Susma, Sri, Vinala, Ayan, Malik. Right answer. First one is better. This is called figure of merit, on the basis of which we can compare the differential amplifier. Figure of merit of not operational amplifier. Figure of merit of what? Any differential amplifier. No doubt operational amplifier is basically a differential amplifier. Okay. Okay. So this is important formula. Yes. So this one. This is important one. Please revise this formula. And this is important one. This two. Okay. Right, CMRR, and if it is a CMRR in dB, then what will be the dB? 20 log of this. 20 log of this. CMRR in dB, it is nothing but 20 log base to 10 of AD by AC, mod of AD by AC. This is the CMRR. Okay. Now always remember, we will solve number of numericals on this circuit in the Gradeup app. Please install Gradeup app and follow me. That is Sanjay Rathi. Then you will get the notification. Next one. Ideal differential amplifier. This is a differential amplifier. Basic diagram of differential amplifier. This is the RF, this is the R1, this is the RG, this is the R2. Sometimes it is V2, sometimes it is V1, sometimes it is V1, that is V2. Don't worry about that. If suppose I am putting the V1 and V2 here, then we can write like this. Let it is a V1, let it is a V2. Or we can write other way. Then what will be the gain of this system? What will be the gain of this system? Directly we can write the equation. Directly I am writing the equation. First of all, find the voltage at this point. So which is important for this? Just I am giving you the answer. Now first one, what is the voltage at this point? And this is multiplied by 1 plus RF by R1. So what is the output? Directly we can write the output. V0 is equal to 1 plus RF by R1. That is the gain of non-inverting operational amplifier into voltage at this point. What is the voltage at this point? Always remember Rg by R2 plus Rg. R2 plus Rg into V1, if it is voltage is V1. This is called output because of non-inverting terminal voltage. Always remember it is a linear integrated circuit so that we can apply the superposition theorem. So I am finding the voltage at this point Rg upon R2 plus Rg V1 multiplied with 1 plus Rf by R1. Now this is 0, the voltage at this point is V2. What is the gain? Minus Rf by R1 into V2. Minus Rf by R1 into what? V2. Now this term is what? A1. This term is what? A2. A1 V1 plus A2 V2. A1 V1 plus A2 V2. You can compare A1 V1 plus A2 V2 and you will get the answer. Right? What is the A1 and what is the A2? If suppose in a particular question they will ask direct question, what is the AC and AD? Then from this you can find what is the AD then? A1 minus A2 by 2. What is the AC then? A1 plus A2. So first of all, this diagram is most important one from the differential amplifier. 5-star rating. Right? So ये है 5-star. Okay guys. Then formula, direct formula. This is the A1 1 plus Rf by R1 into Rg by R2 plus Rg. That is what AD and that is what? Sorry, A1 and A2. And then you have to find this value and that is CMRR. Common mode rejection ratio. Now, what is the ideal condition if this ratio Rf by R1 is equal to what? Rg by R2. First of all, always verify the ratio. If Rf, that is called balance bridge condition, Rf by R1 is equal to Rg by R2, then if Rf by R1 is equal to Rg by R2, then AC will become 0, CMRR will become infinite, and AD will become Rf by R1 or what? Rg by R2. Both are equal. And directly we can write the output AD V1 minus V2. Always remember V1 is a non-inverting voltage, V2 is a inverting terminal voltage. So only two formula. One is what? Practical condition. One is what? Ideal condition. Under ideal condition, always this will satisfy. This equation will satisfy. This is important formula. Right? And this is important, AD. Then directly you use this formula. Okay? Or otherwise this one. So please PDF. Yes. Clear guys? Up to this point, is there is any doubt? You can ask. यार देखो 2 घंटे में बहुत सारे फॉर्मूले, आपको कुछ यूजफुल हो रहा है तो फटाफट देखो, अभी भी उतनी ही स्ट्रेंथ बनी हुई है. लाइक्स भी कीजिए, शेयर कीजिए, राइट, और लाइक और डिसलाइक कुछ तो कीजिए, चलेगा, ठीक है ना. इट इज अ इंपॉर्टेंट सेशन, इट इज अ व्हाट इंपॉर्टेंट सेशन एंड वी कैन रिवाइज ईच एंड एवरीथिंग. नाउ नेक्स्ट वन, रेडी फॉर नेक्स्ट? यस, this is up to what? Differential amplifier. And different types of differential amplifier, we will solve number of numericals on a Gradeup app. Common mode rejection ratio, already there is a formula. And this is what? Instrumentation amplifier. Instrumentation amplifier. Instrumentation amplifier, they simply ask you very simple question, what is the output? Then always remember in this case, directly you can apply the formula. Just I am giving you the formula. How to solve this type of questions? Then in this operational amplifier there is a negative feedback. This will become, if suppose it is a A2, it will become V2. This is a V1, let it is a V1, right? And this is a, let it is a V02, and this is what? V01. The output of this and output of this, and this is connected to what? Operational amplifier. Normally this is R2 by R1, this is the R2 by R1 balance bridge condition. Then output V0 here is given by R2 by R1, V0 non-inverting terminal voltage V02, minus inverting terminal voltage V01. It is basically a differential amplifier. Okay. Now voltage at this point is V02, voltage at this point is V01. The ratio is equal R2 by R1, R2 by R1, and that's why we can directly write R2 by R1 into non-inverting terminal minus inverting terminal voltage. Now you have to find V02 minus V01. It's a very simple. The input resistance of the operational amplifier is 0. The input resistance of this amplifier is also 0. Okay, this is 0. It is because of virtual short concept. So what is the current enter into this? 0. What is the current enter into this? 0. Now, if suppose we are assuming that there is a current, then this current will pass like this, I. And we can write the KVL here, KVL. So what is the V02 is equal to, or directly we can write from the network, V02 minus V01 is equal to I R3 plus R4 plus R3, that is nothing but 2R3 plus R4. And what is I? The voltage at this point is V2, virtual short concept, voltage at this point is V1. Then I is nothing but V2 minus V1 divided by what? R4. And then V02 by V1 will become, V02 minus V01 will become 2R3 plus R4, V2 minus V1 divided by R4. And what is the output then? This is the output, V02 minus V01. So this is multiplied and you will get the answer. What is the complete output? R2 by R1 into divide R4, 1 plus 2R3 by R4 into V2 minus V1. That will be the output for instrumentation amplifier. It is a differential amplifier. It is a very important diagram to measure the difference between the two signal. Right. Technical पढ़ते पढ़ते weak तो गया, क्या हो गया dear? टेक्निकल पढ़ते पढ़ते वीक हो गया बहुत. ओके, वीक मतलब विच टाइप ऑफ वीक? WEAK वीक और वीक पूरा सप्ताह हो गया. क्यों टेक्निकल? ओके अरविंद, व्हाट यू वांट टू से? और नाउ वैभव तिवारी, टेंशन हो रही है. अरे डोंट वरी अबाउट दैट. टेंशन तो लेना ही नहीं है. टेंशन लो मतलब टेंशन दो लोगों को, ठीक है ना? मतलब लोगों को मतलब गेट वालों को दो, गेट में सेंटर पे टेंशन दो. खुद टेंशन लेके क्या फायदा है? जिंदगी बहुत छोटी है, आराम से जियो, मजे करो, आनंद लेने के लिए आए हुए. टेंशन लेंगे तो कुछ होने वाला नहीं. टेंशन इसलिए हो रहा है पता तो मैं आपको, क्योंकि आपने इसको जीने मरने का प्रश्न बना लिया. अरे एक बात बताओ, गेट नहीं होगा तो कुछ हो जाएगा क्या? कुछ नहीं होगा. गेट के बहाने हम लोग टेक्निकल कॉन्सेप्ट सीख रहे हैं. गेट के बहाने हो सकता है गेट में आपका सिलेक्शन लग जाए, PSU हो जाए या कोई नौकरी लग जाए आपकी. और अगर मान लो आपकी नौकरी नहीं लगी, सपोज जॉब नहीं मिलती है या कुछ गेट में अच्छा स्कोर नहीं आ पाता, सपोज एक पॉइंट मान लो, इतना सारा जो नॉलेज लिए हो ना, उसमें से 1% भी यूज करके कोई भी इक्विपमेंट बना देना, कोई भी स्टार्टअप कंपनी खोल लोगे आप लोग मिलकर. तो सब अपना एक दूसरे का नाम नोट कर लो, जो जो अच्छा मतलब जिसके साथ ग्रुप बनाना है ग्रुप बना लो. राइट. ऑफलाइन क्लासेस में तो बहुत स्टार्टअप खुले हैं. अब देखते हैं ऑनलाइन क्लासेस में आप लोग एक दूसरे से कैसे मिलते हो. एंड दैट इज व्हाट, दैट इज द ब्यूटी ऑफ गेट एंड अदर कॉम्पिटिटिव एग्जाम्स. अगर ये कॉम्पिटिटिव एग्जाम्स ना हो ना, तो कोई भी पढ़ाई भी ना करे. इंजीनियरिंग में क्या सीखते हो आपको मालूम है, ठीक है ना? हम लोग को भी पता है हम लोग भी क्या सीखे थे. सर मेजरमेंट पर भी मैराथन लीजिए. ओके ऋषभ मिश्रा, गुड वन, गुड एडवाइस. तो ये एडवाइस मैं आगे फॉरवर्ड करता हूं कि मेजरमेंट पर भी मैराथन होना चाहिए. चलिए आगे बढ़ें. तो ये हुआ इंस्ट्रूमेंटेशन एम्पलीफायर के बारे में. ये पूरा PDF आपको अपलोड होगा. बहुत ही सिंपल क्वेश्चन, सिंपल डायग्राम, बहुत बड़ा डायग्राम बट वेरी सिंपल सॉल्यूशन. ओके देवी, काइंडली स्पीक इन इंग्लिश. ओके, मोटिवेशनल टॉक इन हिंदी, अदरवाइज टेक्निकली आई विल speak in English. Okay, Devi? Don't worry about that. It is everything about what instrumentation amplifier. Now, this formula is very important. How to solve? Already I have given you the solution. Right? Here we are always using what? Ideal differential amplifier with CMRR infinity. AC is equal to 0. Okay? Don't worry about that. Okay, next one. Now, voltage to current converter with floating load. Right? Simply give me the answer. If suppose we want to make a voltage to current converter, then always remember it is not a voltage to current converter. Suppose if we are giving like this, voltage to current converter means it is RL, it is RS. This is not a voltage to current converter. IL is equal to Vs by Rs plus RL. It is not a voltage to current converter because IL depends upon the RL. IL depends upon RL. And that's why it is not a voltage to current converter. Right? Now in this diagram, if it is a Vin, the voltage at this point is also Vin. That is, or Vs. We can write it like this, Vs, this is a Vs. Now, what is the current here? Vs minus 0 by R. This is the Vs by R. This is the current. The same current will pass through this RL. This is the Vs by R. Now, it is independent of value of RL. And that's why it is called what? Voltage to current converter. Simple. Now, directly objective question they will ask, what is the current here? So, always remember, according to virtual short concept, it is a Vs, it is Vs. So, what is the current here? Vs by R, what is the current enter into the operational amplifier? 0. Then same current will pass through the RL. And that's why I naught is given by Vs by R. It is independent of RL. Right? Finished? Is there any doubt? Okay. Then next one. It is another voltage to current converter. Right? So this one is what? With virtual short concept with floating load, and that is called what? Again, this is a signal here. We are connecting like this. We can find the value. Always find the what? Virtual short concept. Right? And then you will get the idea. What is the virtual short concept? You always find the voltage at this point. This is Vp and that is what Vn. There is a negative feedback. Then Vp is equal to what? Vn. And you will get the value. Oh, Ms. George, what is your name? Myself, Sanjay Rathi. Simple. And then, just I am giving you one important diagram, most important one, this one. This diagram is most important one. This one. This is called what? Voltage to current converter with grounded load. In this diagram, always check the ratio. RF by R1 is equal to RP by R2. If suppose the input is connected here, it is connected to ground. For example. Then always check the ratio. RF by R1 is equal to RP by R2. If this is the case, RF by R1 is equal to RP by R2. Then the current through this RL is given by Vs by R2. Vs by R2. If at the same time, if Vs is connected to non-inverting terminal, suppose that is the second case, if Vs is connected to non-inverting terminal, then again check this ratio and then I0 is equal to minus Vs by R2. Minus Vs by R2 if the input is connected to inverting terminal, means here. If Vs is connected to positive terminal, plus Vs by R2, if it is connected to negative terminal, minus Vs by R2. In both the cases, the magnitude will remain same. That is called what? With grounded load. Okay, with grounded load. Right. Okay. Oh, लगातार यहाँ तो लाइन लग गई. What is your name, sir? Thank you, मयूर. Right. अपना नाम अपने से बताओ तो थोड़ा सा लगता है ना, क्या बार बार सर अपने ही बारे में बताते रहते हो. ठीक है. Thanks for that. Next one. Next one, if suppose this ratio is not equal, Rf by R1 is not equal to what? Rp by R2, then we have to solve the question. Always remember in this case, that circuit design is just like that. The negative, we are having the two feedbacks, negative feedback and what? Positive feedback. Negative feedback and positive feedback, the negative feedback is dominant. Negative feedback is always greater than what? Positive feedback. And that's why virtual short concept is valid. What is the virtual short concept? Vp and Vn. Virtual short concept is valid, then Vp is equal to Vn. Then what will be the procedure to solve this question in a GATE exam? What will be the procedure? It is one of the most important diagram. Very important diagram. First of all, check the ratio. Rf by R1 is equal to Rp by R2. If this ratio is satisfied, then again check whether Vs is connected. If it is connected to non-inverting terminal, Vs by R2. If it is connected to inverting terminal, again minus Vs by R2. First method. Second case, if this ratio is not satisfied, if Rf by R1 is not equal to what? Rp by R2, then what will be the method? They may ask, it may be a 2 marks question. Then don't worry about that. Vp is equal to Vn. Find the Vp. Always remember, current enter into the operational amplifier is 0. Current enter in this terminal is also 0. Now find the Vp by applying the KCL. Vp minus Vs by R2, Vp minus 0 by RL, Vp minus V0 by Rp. And then apply the KCL at this point. Vp minus 0 by R1, Vn minus 0 by R1, Vn minus V0 by Rf. Always remember Vp and Vn are equal. Then find the value of Vp. You will get the two equations, right? And then use this formula Vp is equal to Vn and find the value of Vp. And finally find the value of I0 is equal to Vp by RL. Direct method. Okay guys, it is clear. Now we can solve this type of question within 2 minutes. If it is satisfied, 30 seconds. Not satisfied, within 2 minutes we can solve. So write down the KCL at this point, write down the KCL at this point, find the Vp and Vn, equate them and find the value, finally find the value of Vp, Vp divided by RL. It will be the method. Up to this point, is there is any doubt in this diagram? In this particular diagram, is there is any doubt? Brilliant. Oh, directly good afternoon, good evening, सीधा डायरेक्ट गुड नाइट हो गए तो कोई बात नहीं चलेगा. चलिए मुस्कुराहट तो आनी चाहिए किसी. ब्रिलियंट. व्हाट्स योर ब्रांच माय डियर स्टूडेंट? तो देवी, nowadays everything is fine for you. Rishabh, are you getting me? About how many students are attending the class? Please like the session and subscribe the channel. Everything is clear up to this point? Now, next point. Next one. Application. This is because it is a MSQ, multiple selection questions. So voltage to current converter, low voltage DC and AC voltmeter, diode match finders, light emitting diodes, Zener diode tester. This is important application of this. These are the application of voltage to current converter. Voltage to current converter. Okay. Now next one. हाँ ये आपने सही बोला. That is from. Now you are from triple E. Okay. And again that analog is analog will play important role to get what single digit rank or what 2 digit rank. Without analog it is not possible to get whether it is a electrical branch or electronics or what instrumentation. Now next one. This is simply what voltage to current converter. Always remember, if it is connected like this is 0, this is also 0. What is the current through this R? 0. Current through this R is 0. The complete current will pass through this RF. Why? Because it is 0, virtual short concept. Vn 0, nothing. Then this complete current will through RF and this is 0. So what is the V out? V out is nothing but I in into RF with negative sign. This is the path. And then this voltage, this current is converted into what? Voltage. Here we are connecting the RL. Here we are connecting the RL. This is called current to voltage converter. Now the output voltage is independent of what? RL, because we are connecting RL here, and that's why it is called current to voltage converter with negative sign. Right? Then now what is voltage follower? It is simply voltage follower. It is a special case of non-inverting operational amplifier. Voltage follower, right? In a voltage follower, in case of non-inverting operational amplifier, what will be the gain? This is a non-inverting operational amplifier. What is the gain? 1 plus R2 by R1 or 1 plus RF by R1. If it is RF, if it is R1, 1 plus RF by R1. If this term is negligible, this term is negligible as compared to 1. And when it is possible, R2 by R1 is very small as compared to 1. Or R2 or RF is very small as compared to R1. Then we can neglect this term, and this is gain is nearly equal to 1. Output voltage follow the input voltage, and that's why it is called what? Non-inverting operational amplifier and voltage follower. Phase shift is 0. This circuit is known as voltage follower. Due to gain 1, it is also called as unity gain amplifier or buffer. This is the name. Okay. What are the applications? So again, for new student, please go through it. There is a series on a Gradeup app, complete revision up to 31st. थोड़ा पानी पी ले जाए आप. और this is a complete series. अगर आप जीरो से भी स्टार्ट कर रहे हैं ना, तो भी आपका पूरा एनालॉग एक बार तो अच्छे से क्लियर हो जाएगा, ताकि आप क्वेश्चन बना सको. इलेक्ट्रिकल वालों के लिए बहुत ही इंपॉर्टेंट है, because we are getting the question from CMRR, integrator differentiator, Allen K filters, different types of symmetry trigger. Relaxation oscillator means what? Square wave generator. Okay, relaxation oscillator means square wave generator. And then everything about the rectifiers and filters, clipper and clamper, biasing. It is designed for what? Electrical, electronics and instrumentation branch. These all topics are important. Next one. Okay. Up to this point, it is a voltage follower. Voltage follower means simply the phase shift is 0. And the feedback mechanism is what? Voltage series feedback. It is just a special case of non-inverting operational amplifier. Go through the formula of non-inverting operational amplifier. Every formula is valid here. Every formula is valid here. Please give me the value of beta here. Everyone, what is the value of beta for non-inverting operational amplifier? Sorry, voltage follower. This is a voltage follower. And this is the VS. It is a special case of non-inverting operational amplifier. Every formula is valid. That is the AVF is equal to AV upon 1 plus beta AV. Right? RIF is equal to what? RI into 1 plus beta AV. R naught is equal to R naught F. This is with feedback upon 1 plus beta AV. Feedback mechanism is voltage series feedback. What is the value of beta for this diagram? What is the value of beta for this diagram? Beta, feedback factor. Right. What is the beta? R1 upon R1 plus RF. This is the beta. And everyone please tell me. No, where is the R1 and where is the RF? Nothing is here. What is the value? So always remember, this is what? 1 upon 1 plus RF by R1. And for for voltage follower, RF by R1 is very less as compared to 1, and that's why this is negligible. Beta is nearly equal to what? 1. Beta is nearly equal to 1, right? Beta is nearly equal to 1, and always that is the AVF 1 plus RF by R1. This RF by R1 is negligible as compared to 1, and that's why gain is nearly equal to 1. That is the concept. That is the concept. Okay, Kirti, right answer. That is beta is exactly 1. Right? Then this is the formula. Always remember this formula. What are the application of that? What are the applications? voltage follower is used in designing of first order Butterworth filter. It is used for impedance matching between high impedance and what low impedance, and what it is used in designing of sample and hold circuit. Sample and hold circuit. Okay, these are the applications of voltage follower. Now, what is a linear wave shaping circuit? A linear wave shaping circuit means what? Simply we are providing high pass RC circuit and what? Low pass RC circuit. You can go through the definition, but definition is not required. Just process. The process whereby the shape of non-sinusoidal signal is altered by transmission through a linear network is called linear wave shaping circuit. Linear wave shaping circuit. For example, these are given as high pass RC circuit. This is the high pass RC circuit. It is a linear wave shaping circuit. And second one is what? Low pass RC circuit. Direct idea about the high pass RC circuit and low pass RC circuit. Okay, first. Now, this is what? Capacitor, and this is resistor. It is a high pass RC circuit. Second thing, if we are talking about the curve, frequency response curve, this is the curve for high frequency response, and this is the phase shift. Exactly at 0 degree or 0 hertz frequency, the phase shift is 90 degree, gain is 0. At cutoff frequency, the cutoff frequency FC is given by 1 by 2 pi RC. The gain will become 1 by root 2 and the phase will become 45 degree. And exactly at infinity, the gain will become 1 and the phase shift will become 0. It will pass the high frequency signal and stop the low frequency signal. This is a simple idea about that. Second most important thing, here between input and output there is a capacitor. Always remember, between input and output. Yes, Devi, Anusuya, I am explaining that linear wave shaping circuit means when we are passing the signal. For example, this is the high pass RC circuit and what? Simply low pass RC circuit. Now, high pass RC circuit and low pass RC circuit. These are the two linear wave shaping circuit. Because we are using the simple element, simple passive elements RC. Right? We can apply the superposition theorem. It is a homogeneity and scaling is applied, applicable, and that's why it is what? Linear circuit. Wave shaping, what is the meaning of this? Wave shaping means, suppose we are passing, this is the integrator and that this is the differentiator. Everyone please give me the answer. If I am differentiating the signal sine omega t, what will be the answer? Sine of theta. I am differentiating the signal sine of theta, then what will be the answer? Everyone please give me the answer for this question. This is nothing but sine of theta plus 90 degree. Sine of theta plus 90 degree means what? Cos theta. Cos of theta. What is the shape of the sinusoidal signal? This is the sine theta. What is the cos? This is the cos signal. Right? There is no change in shape of the signal. No change in shape of the signal if we are passing the sinusoidal signal. Only there is a change in what? Phase. Only, yes. It is for electrical, electronics and instrumentation. Just I am covering each and every point. This is a very important point. Okay, Manikant. Right? This is the value. But what about the shape? Both are sinusoidal. No change in shape. Only change in what? Phase. Only change in phase. Similarly, when we are using integration, right? And then what is the integration? Integration means what? Cos, if we are giving the cos theta, then we are giving the cos of theta minus 90 degree. It is one is what? Leading circuit, one is what? Lagging circuit. Then cos of theta minus 90 degree is nothing but sine of theta. Always remember this diagram. This is a cos, this is what? Sine, minus sine, this is what? Sine, and this is what? Minus sine, minus cos. right? If we are giving the negative, this is the in a clockwise direction negative angle, in a anti-clockwise direction it is the positive angle, right? So this is a minus 90, and that's why we are getting the sin theta. Again the shape will remain same, only change in phase. But when we are integrating the square wave, what will happen? When we are integrating the square wave, we are getting the triangular pulse. Change in phase as well as change in what? Shape of the signal. And that's why this topic deals with non-sinusoidal signal. Non-sinusoidal signal. Okay, dear students, this is a non-sinusoidal signal, because when we are passing the non-sinusoidal signal from high pass RC circuit or low pass RC circuit, there will be a change in phase as well as there will be a change in shape of the signal. And that is the definition. The process whereby the shape of the non-sinusoidal signal, this is the key word, non-sinusoidal signal. This is the key word, non-sinusoidal signal, is altered by the transmission through a linear network. Linear network means simple RC circuit. Now it is clear? Yes. We are getting the triangular wave. And then when we are passing the high pass RC circuit, always remember, just I am giving you the high pass idea about the high pass RC circuit. It is a leading circuit because the phase shift is positive. Capacitor of this circuit blocks the DC signal, because this capacitor, the impedance is equal to 1 by 2 pi FC. For DC, F is equal to 0, then ZC is equal to infinite. It will block the DC signal, and that's why always remember the DC at the output is always 0, because the DC is blocked by what? C. And therefore average value of the output is always 0. Right? They will ask question like this: when we are passing particular signal through a high pass RC circuit, then what will be the DC of the output? The DC of the output is 0. DC of the output is 0 because DC is blocked by this capacitor. Second thing, and that is a high pass filter. This is the characteristics of high pass filter. This is a phase shift. Third thing about that, as a differentiator, when a high pass RC circuit will act as a differentiator, always remember two conditions in case of high pass RC circuit. If the phase shift is given by tan inverse of 1 by omega RC, right? The phase shift of high pass RC circuit is tan inverse 1 by omega RC. If RC is very large as compared to what time period of the signal, omega is equal to 2 pi f, that is nothing but 2 pi by t. Very large, then phase shift is nearly equal to 0, and the shape of output is similar to shape of input. Pulse shape will be preserved. Pulse shape will be preserved. This is a very important concept. Means if we are giving this type of input, right, and then we are getting this type of output, right, if RC is too high. Second case, if RC is very small as compared to T, then the phase shift is nearly equal to what? 90 degree. Then there will be a differentiation of the signal. Differentiation of the signal. And what will be the output? If suppose we are giving the pulse, then the output like this, we are getting the impulse. We are getting the impulse at this point and one at this point. This is called true differentiation of the signal. What is the differentiation of pulse? What is the differentiation of pulse? Impulse. Simple. But condition applied. RC should be very small. Then the phase shift will be exactly 90 degree. Yes. Right. Then what is the cutoff frequency for that? Okay. So my dear students, is it clear to you? Yes or no? Right. So there are two terms. Right. This is the phase curve. Phase means when the frequency of the signal is 0, then again we are getting the phase shift 90 degree, then there will be a differentiation of the signal. When the frequency of the signal is 0, again we are getting the 90 degree. But when RC is too high, then phase shift 0, RC is too low, then phase shift is 90 degree. This is important point about what? High pass RC circuit. Okay. Next one. These all points are very important. Okay. Then next one. Direct question. अभी देखिएगा एनालिसिस होगी. We will provide you the analysis for a GATE exam. Then again you will get which topics are important. Then low pass RC circuit. Simple low pass RC circuit, it is also called as lagging circuit. The capacitor of this circuit converts the DC signal. Always remember, the DC of the output is always equal to DC of the input, because here we are using the capacitor. DC of the output signal is always equal to DC of the input signal. Second thing, that is the frequency response curve. It is a low pass filter. Low pass filter, right? The phase shift is given by minus tan inverse omega RC. It is a lagging circuit because it is a negative phase shift. Second thing, two cases here, right? If the phase shift is equal to 0 degree, means RC is what? Very small as compared to T, then pulse shape will be preserved. Pulse shape will be preserved. Means, what is the meaning of this word? If suppose we are giving the input to the low pass RC circuit like this, then we will get the output like this. Right? This is the case. This will be the case. Output like this. If RC is very high as compared to T, then phase shift is nearly equal to minus 90 degree. Then there will be an integration. If suppose we are giving the signal like this, then what will be the output? What will be the output? 1 minute. Yes, this will be the input, and then what will be the output? Like this. And that is approximated triangular wave. Okay, so this will be the case when RC is very high. Okay, then next one. So integrator, this is an integrator. Now first order filter by using voltage follower. These are the application of the filter. This is the low pass circuit. Always remember, this is a low pass RC circuit. Okay, it is that previous one is the passive filter, it is an active filter. What is the cutoff frequency for this? 1 by 2 pi RC. What is the gain of this voltage follower? Always remember, the phase shift is 0 and the gain of this voltage follower is 1. And that's why the gain of the system is decided by this value. Always remember, you have to find the value of Vp at this point. And what is the Vp by Vn? It is nothing but V0 by Vn, because Vp is nothing but V0. And this is nothing but 1 by Sc upon R plus 1 by Sc. And that is 1 upon 1 plus SCR. And you can replace S by 1 plus J omega RC. Because S is equal to what? J omega. Very simple. Always remember, this is what Vp is nothing but equal to V out. Voltage follower. You have to find the Vp in terms of Vin, and that will be the gain. It is a simply low pass filter. We are using here voltage follower. Direct question from this diagram. Okay, direct question. It will avoid what? Loading effect. It will avoid loading effect. Now load is connected here. RL is connected here. And the input resistance seen by this diagram, is infinity. And that's why there will be a no loading effect. Right? if we are changing the value of RL, it will not affect the performance of this circuit. The cutoff frequency will remain same 1 by 2 pi RC, and the gain will remain same 1 upon 1 plus j omega RC, because both are independent of RL. Okay. Then that is the curve. In case of first order, this is the case. In case of second order, this will be the line. Third order, fourth order, fifth order, sixth order. What is the ideal condition? Always remember, ideal low pass filter means this. This is called pass band and this is called stop band. That is called cutoff frequency. But it is not possible. In a first order, this is the gain. Second order, minus 40 dB per decade. Third order, minus 60 dB per decade, and so on. And that's why when we are increasing the order, it will reach near to what? Ideal condition. But the complexity of circuit will increase. There may be a chance of instability. Okay. And that is normally we are using up to what? Second order condition. Second order. Then again, this is the list. I will provide you the list on what a Gradeup YouTube channel, that is a Telegram channel. And we will start our session from 25th of Jan, complete revision with the differential amplifier, integrator, then symmetric trigger, relaxation oscillator, rectifier and filter, clipper and clamper, and so on a Gradeup app. It is not on a YouTube, it is on a Gradeup app. So what about the YouTube? Complete revision of formula of what? Analog. Complete revision. Evening 9:30 to 11:30. Again, it will be very important because we will revise each and every formula of what BJT, MOSFET and so on. So that is information for you. And this is a, please take a snapshot and note the point. Evening 8 p.m. Done. Second order low pass filter. If suppose we are using the C here, R here, this is called second order low pass Butterworth filter. Again in a lecture I will give you the idea about what Sallen-Key filter and Butterworth filter, what about the response and everything. Now this is RC. Directly remember FC is equal to 1 by 2 pi R1, R2, C1, C2. If these are equal, then 1 by 2 pi RC. Normally this is what R1, C1, R2 and what C2. The maximum gain of this system, it is R dash. Then always remember the maximum gain is given by 1 plus RF by R1 dash. This is the 1 plus RF by R1 dash. It will be the maximum gain of the amplifier. Menti quiz tomorrow 9:30. Tomorrow at 9:30 p.m. Again, there will be a session of 2 hours, Maha Marathon. That is a part of what Maha Marathon, and some topics are left. Again, that will be on analog tomorrow 2 p.m. Then Menti quiz 9:30 tomorrow. And then, and for every notification, join our Telegram channel. This is what second order low pass Butterworth filter. It is a low pass filter. If we are changing the position, if we are using the C here, R here, C here, R here, then it will convert it into what? High pass second order Butterworth filter. Simple. Formula will remain same. The formula for cutoff frequency will remain same. The maximum gain will remain same, but simply it will convert into what? High pass filter. This is a low pass filter, and that is what high pass filter. The formula will remain same. Now, if now first order high pass filter, first order low pass filter, second order high pass filter, second order low pass filter. Simple, you have to change the position of what? C and R. Now if we want to make what? Band pass filter, then band pass filter is nothing but high pass filter followed by what? Low pass filter. High pass filter followed by low pass filter, it will convert into what? Band pass filter. If the cutoff frequency of band pass filter is F1 and if the cutoff frequency of low pass filter is F2, then what will be the relation between F1 and F2? Everyone please give me the answer for this question. First option, F1 is equal to F2. Second option, F1 greater than F2. Third option, F1 less than F2. Fourth option, I have no idea, none of this. Yes, everyone. we can design a band pass filter by simply high pass filter followed by what? Low pass filter. तो guys थोड़ा like करो, share करो. ये तो बिल्कुल 28 watching, बस कोई बात नहीं. नो डाउट अभी एग्जाम पास में है, थोड़ा सा रिवीजन भी तो करना, कितना पढ़े आखिर, कई लोगों की ये भी प्रॉब्लम है. तो फटाफट शेयर कर लीजिए, लाइक करो, सब्सक्राइब करो और देखिए जरा कि किसमें कितना है दम और कैसे क्वेश्चंस आएंगे. डायरेक्ट क्वेश्चंस आने वाले हैं इसमें से. F1 less than F2. Yes, this is the right answer. It is not the right answer. C is the right answer. F1 is less than F2. Always remember. This is a high pass filter and this is followed by what? Low pass filter. This is F1. This is called FL. And this is called F2, FH. This is a high pass filter, and this is what? Low pass filter, F1, F2. It is always remember F1 is less than F2, and what is the bandwidth of this? F2 minus F1. F2 minus F1. Now, what is the band stop filter? Band stop filter is what? High pass filter followed by what? Low pass filter. High pass filter followed by low pass filter. Now in this case, if the cutoff frequency of this is F2, if the cutoff frequency is this one is F1, then कुछ गलत तो नहीं लिखा हुआ है ना? नहीं है, यहाँ तो सब सही है. Yes, high pass filter F2 and low pass filter is F1. We are using the adder. This is also called band reject filter or band eliminate filter. Then now what will be the relation? Now in this case F2 is greater than F1. The cutoff frequency of high pass filter is greater than cutoff frequency of what? Low pass filter. Okay, this is called band reject filter. Always remember this type of curve. This is a low pass filter, this is the F1, this is a high pass filter, this is the F2. F2 is greater than F1. Low pass filter, high pass filter. High pass filter. What is the bandwidth of notch filter? F2 minus F1. Bandwidth is given by F2 minus F1 for band stop filter. So this is all about the band stop filter. When bandwidth is very low, that is called narrow bandwidth, then it is called notch filter. Right? Then it is called what? Notch filter. If the bandwidth is very small, then it is called notch filter. Okay, means what? This bandwidth, this bandwidth. Let this is a very small, this bandwidth is very low. This is F2 and this is F1. This is called notch filter. Notch filter is nothing but a special case of band stop filter. Normally practical diagram like this, F0. Okay, high pass filter, parallel connection, twin T network, like network. This is a high pass filter, parallelly connected one low pass filter. This is the low pass filter, parallel connection. This is called twin T network, right? So this is RC. This is C dash, and what R dash. High pass filter, low pass filter connected in parallel. This is called notch filter. Notch filter. Twin T network. Okay. Where we can use the notch filter? In a power supply, right? To reject the power supply noise. Power supply noise means when we are communicating, it is what? Frequency from 20 Hz to 20 kilohertz. When we are communicating, then there will be a noise because of power supply room. And what is the frequency of that power supply? 50 Hz, 100 Hz, 150 Hz. These are called harmonics of what? 50 Hz, because power supply is at 50 Hz. and we have to reject all these frequencies because these are noise, and that's why we are using this type of filter to reject particular this. In America it will be 60 hertz, 120 hertz, 180 hertz. These are the noise, and these are called notch frequencies, and we want to reject it. Okay? Yes. Yes. To reject noise. To reject noise. Next one. All pass filter. All pass filter means it will pass all the signal frequencies without any amplification or what? Attenuation. Without any amplification or attenuation. Oh, Devi, Tinti, sorry, what is this? Tinti filter. Is there any another name? Sorry, I am not having any idea. I will verify it. If suppose it is a right, then okay. It is a Tinti filter by Devi. Then we will check. And then Ajay Kumar, how are you? What's your branch? Yes, to simply reject what noise? Power supply noise. We are using the notch filters. Now it is a all pass filter. Always remember these two resistors are equal. And if it is just similar to what high pass filter, then the phase shift provided by this is what 0 degree to 180 degree. That is a simple case. Right? It affects the gain margin and phase margin of the system. In a control system, we are using the magnitude will always remain 1. Right? It will introduce a phase change. What is the phase change? From 0 to 180 degree positive value. And then second diagram for this. Second diagram. If suppose let this type of diagram. Always remember the value of these two resistors equal. These two are connected. If it is like a low pass filter, R and C, it is just a low pass filter. Always remember the low pass filter, the phase shift is given by from 0 to what? Minus 180 degree. Negative phase shift, or we can say like this, minus 180 degree to what? To up 0 degree. So because we can remember this formula, it is a lagging circuit. And previous one is what? Leading circuit. It is a high pass filter. High pass filter is what? Leading circuit. The complete diagram is what? Complete diagram is all pass filter. Okay. Twin T filter. Okay. That is the network. What is the name of this? Twin T network. Because we can separate these two. This is the connection of these two. This is called high pass filter. We can find the Y parameter of this high pass filter, and that is what? Low pass filter. 2T network, that is called twin T network. Twin T network. Okay. When we are connecting like this, it is connected in parallel. We can calculate the Y parameter of this. Yes. Wow. Gain margin and phase margin. In a Nyquist and what is the Bode plot? It is a method to analyze the circuit. Yes, simply we can we are connecting the all pass filter, and then we can change the point. Right? That is called what? Phase crossover frequency. We can change the point of phase crossover frequency because we are calculating the gain margin at phase crossover frequency. Then we can change the gain margin when we are connecting, but it will not affect the magnitude plot. Why it will not affect the magnitude plot? Because the gain is what? 1. All pass filter will only affect the phase curve. It will not affect the gain curve, and then we can calculate. Yes. Okay. Now next one. All pass filter. This is the all pass filter. Now the practical operational amplifier. Always remember, for practical operational amplifier, gain is not infinite, right? Then the characteristics will start like this. This is the characteristics. It is called positive saturation. It is called what? Negative saturation. When we are giving the inputs, after some time operational amplifier will enter into saturation. Okay, this is the practical characteristics of practical operator. What is the meaning of characteristics? V0 versus VD. What is the VD? The voltage between these two terminals. This is the voltage, and this is the output, and this is the plus V set and minus V set. Output will never exceed the plus V set or what? Minus V set. The range of the output is always between this minus 15 and plus 15. Energy can neither be created nor be destroyed. Okay, that's why. Then this is again the list. Please take the snapshot of this. For new students, some students are coming here, and then for new student it is a series, a list of series on an app. That is rapid fire revision series on app. For analog, complete revision. So first of all, go through each and every formula today at 9:30 to 11:30, and then what? 11 to 1 p.m. and then please attend these classes. Total 1, 2, 3, 4, 5, 6, 7, 8 classes. These 8 classes are very important for GATE 2021. Here we will discuss only numericals, important and probable numericals, right? Typical numericals with each and every concept. Ajay, sir, this filter can be used as a proportional controller and low pass filter as a differential controller. High. It is a question of what? Control system, not here, Ajay. It is a subject what? Analog. It is not a, no doubt. In a control, I will give you the idea about that. I have to start control system also on a Gradeup app. Then, no, don't worry about that. Now, with positive feedback, when we are providing the positive feedback, then when we are giving the positive feedback, then 3 types of devices, normally multivibrators, bistable, monostable and astable multivibrator, and then what? Triangular wave generator, and then square wave generator, relaxation oscillator. That is the operational amplifier. The circuit which can oscillate at number of frequencies is called the multivibrator. Multivibrator is used to implement the simple two-state systems such as oscillator, timers and what? Flip-flops. Two-state system means what? The operational amplifier has 2 outputs, plus V set or what? Minus V set. And this is called 1 high level and this is called 0, that is called low level. In case of flip-flop, only 2 levels, positive levels and what? Negative levels. Timing 8 to 9 p.m. Timing 8 to 9 p.m. Evening. It is on Gradeup app application. 8 to 9 p.m. Daily 1 hour class, and today at 9:30 p.m. again there will be a class on YouTube channel 11:30 p.m. Remaining part of analog. Now next one, types of multivibrator: astable, bistable and what? Monostable, right? Then what is the bistable multivibrator? Everyone, 0 to 1 with trigger. Without trigger there will be no change. 1 to 0 again with trigger, right? And that is what? Both the states are stable, and that's why it is called bistable. Example, simple flip-flop, binary. It is also called binary or flip-flop. Both the states are stable. Without trigger there will be no change in the state. Second one is what? This is the diagram for bistable multivibrator. It is what? Nothing but symmetry trigger. Normally it is a symmetry. It is also called comparator. Yes. Right? What is the name of that circuit? Comparator or symmetry trigger. Now, what is a symmetry trigger? And this simply symmetry trigger. When we are giving any type of waveform to the symmetry trigger, it will convert it into what? A square wave. Simply, that is a symmetry trigger circuit. In a circuit which converts the sine wave into a square wave, triangular wave into a square wave, or any waveform into what? A square wave. The output of symmetry trigger is a square wave. It is also has two opposite operating state as in all multivibrator. In this case, the triggering signal is slowly varying AC voltage. Yes. If we are giving the sinusoidal signal, this is called slow varying waveform. It will convert into a square wave, that is called fast varying waveform. It is a slow varying waveform. It is a fast varying waveform. Right? Fast varying, fast change. Fast change means what? From minus V to plus V. What is the time taken by the signal? Almost 0. From plus V to minus V, almost 0. But it is a slow varying waveform. Man, MSQ. It will give you the point, which points are correct. One point will be that the symmetry trigger can convert a slow varying waveform into a fast varying waveform. Then this statement is right. This statement is what? Right. तो सबके सब देखो भैया MSQ पूछा जाएगा और MSQ में आपको जवाब देना है. MSQ. Okay? Then multiple selection question. Now try to understand symmetry trigger. This is a basic diagram of what symmetry trigger. Basic diagram. Here we are giving the input. This is the input. And this is what feedback, positive feedback. And because of positive feedback, the output has only two levels, plus Vset and minus Vset. Plus Vset and minus Vset. This is a VR. And we will discuss 5 types of symmetry trigger. 5 types of symmetry triggers in our Gradeup app. Just I am giving you the important points about the symmetry trigger. Here it is a positive feedback. It is also called practical comparator. It is a practical comparator. Or it is also called regenerative comparator. Regenerative comparator. Why? Because what is the another name of positive feedback? Regenerative feedback. And that's why it is also called positive feedback or regenerative comparator. This is a regenerative comparator. Here then one is the reference voltage is connected here. This is called reference voltage VR. This is a variable DC signal. And then R1 and R2. Always remember we have to calculate the threshold voltage at this point. Now current enter into the operational amplifier is 0 because the input resistance is almost infinite. You can calculate the voltage at these 2 points for 2 different values of Vset. One is what? Plus Vset. One is what? Minus Vset. And that is called upper threshold and lower threshold voltage. What is the upper threshold? Vset into R2 by R1 plus R2 plus VR into R1 by R1 plus R2. Always remember how to revise this formula. Plus Vset into R2 divided by R1 plus R2 plus VR into R1 divided by R1 plus R2. That will be the formula for upper threshold. What is the lower threshold? Direct minus Vset. R2 divided by R1 plus R2 plus VR R1 divided by R1 plus R2. And the difference between upper threshold and lower threshold is called hysteresis voltage. Hysteresis voltage is VUTH minus VLTH. That is 2 times of Vset divided by R1 plus R2 into what? R2. Sometimes this R2 by R1 plus R2 is also called beta or alpha. In different books we are using like this. R2 divided by R1 plus R2. Then this will become 2 times of beta Vset. This will become 2 times of beta R2 by 2 times of beta Vset. What is this? Upper threshold level, lower threshold level. Always remember in this diagram, find upper threshold, lower threshold, and then what? Hysteresis voltage. This is important. And you can solve any 2 marks question. Right? Always check the upper level and lower level. Normally this is what? 15 volt, then it will be minus 15 volt. But sometimes it will be what? 10 volt, it will be a 0 volt. Then you have to check. What about the positive value? What about the negative value? Otherwise, you will make silly mistakes. Okay? Always remember. Now, you will make the silly mistakes. Now, what about the hysteresis voltage? It is independent of value of VR. It is independent of value of VR. Now, what is the next point about that? Next point about the symmetry trigger. 2 types of symmetry trigger. Always remember, means what? In one case, it is connected to, this is feedback will remain same, feedback like this. This is the input. Input is connected to what? Negative terminal. In this case, first of all, find the upper threshold and lower threshold level, and always remember the curve. What about the curve? One minute. This type of curve. Right? And this is the curve. Anti-clockwise direction. This is the upper threshold and this is what? Lower threshold, VLTH. Upper threshold and lower threshold. And the gap between these two is called hysteresis voltage. This is important. This is very important. If the input is connected to what? Negative terminal, and then this will be the graph. And you can find the upper threshold and lower threshold by using this method. Both may be negative, both may be positive, or one may be negative or one may be positive. It is possible. Right? You have to find the value. Then second one, if this type of connection, right, this is a positive feedback plus, but this point is connected to ground, and this is what R2 and this is R1. Now the input is connected to what? Inverting terminal. Now the input is connected to what? Non-inverting terminal. Then what about the hysteresis loop? Hysteresis is connected like this. Okay then, now try to understand. Again we are getting the curve, but this time anti-clockwise direction. This time is what? Anti-clockwise direction. Means what is the meaning of that anti-clockwise direction? Suppose the input is highly negative, then output will be what? Negative. If input is negative, output will be negative. We will start with this, right, like this, right. After that, this will be the path. Anti-clockwise direction. This will be the path. Okay, always remember this diagram. And again, this is what? Upper threshold level. Upper, and this is called lower threshold level threshold. Yes. Okay guys, it is clear to you. This is upper threshold level and lower threshold level. Again the hysteresis voltage will remain same. VH is equal to VU minus VL. These are two types of diagram. In one case it is connected to what? Negative terminal, inverting terminal. In other case it is connected to what? Positive terminal. In both the cases the feedback is positive. Then how to calculate the upper threshold and lower threshold? Always remember by using this. You have to find the voltage at this point VB and equate with this VA. That this VA, in this case VA is equal to 0. Then find the voltage at this point. What is the voltage at this point? Always remember the voltage at this point is given by V0 into R1, that is R1 upon R1 plus R2 into what? V0 plus R2 divided by R1 plus R2 into what? Vi. This is the voltage at this point VB. Now for two different values of V0, we have to equate this with what? VA. Right? What is the first value? R1 divided by R1 plus R2 into Vset plus R2 by R1 plus R2 into what? Vi, equate with what? VA, and get the value of Vi. get the value of Vi in terms of Va. In this case, the Va is 0. In this case, the Va is 0. You will get the value of Vi, one value of Vi. In the second case, again, use this formula R1 upon R1 plus R2 into minus Vset. Just I am giving you the most important formula. R2 divided by R1 plus R2 into general form of Vi, equate with it to what? Va. In this case, again the Va is 0 and you will get the value of what? Vi. This time it is what? Negative. If Va is 0, you will get the value Vi is equal to Vset R1 by R2. If Va is 0, from this formula, you will get the value of Vi is equal to Vset with negative sign R1 by R2. Right? Now, this is called lower threshold and that is called what? Upper threshold. Well, Va is equal to 0. This is a higher value, this is a lower value. Otherwise, you will get the value in terms of what? Va, capital Va. And that is called how to solve this type of question. Complete idea about this diagram. Complete idea. Right? So, ये है value. Upper threshold, lower threshold. And what is the difference? Clockwise, and this is what? Anti-clockwise. Now, last point. First stable multivibrator, this is a 0 to 1, 1 to what? 0, without trigger, with trigger, without trigger, no need to apply the trigger. Always we are getting the output like this, 0, 1, 0, 1, 0, 1, 0, 1. And both the states are quasi-stable and that's why no state is stable and that's why it's called a stable multivibrator. 0, 1, 0, 1, 0, 1. Without any trigger. And that's why it is called what? Free running multivibrator or square wave generator. Free running multivibrator is square wave generator. Right. Now, this is the diagram, standard diagram for this relaxation oscillator. That is what? Square wave generator. This is R1, that is R2, this is the RC, this is R and this is C. Now, Schmitt trigger can convert a sinusoidal waveform into a square wave. It requires input, it requires trigger. Schmitt trigger is a bistable multivibrator. But without any input, we can get the square wave here. Without any input. And that's why it is a square wave generator. Now, at output we are getting the square wave. At this point again we are getting the square wave, that is called attenuated square wave. And at this point we are getting the just approximated triangular wave. This is the value. This is the value. This is the voltage across the capacitor. This is the output voltage. And at this point again we are getting, that is a non-inverting terminal, we are getting the square wave. Always remember, my dear students, what is the difference? That Vp is not equal to Vn. Vp is not equal to Vn. Yes, it is just over. Within 5 minutes we will cover because we are having one topic only and that's just the duration is what? 2 hours, 11 to 1, already it is 1. Now just I am giving you the last diagram. This is an important one. Okay. This is in a one diagram you will get the idea how to solve this. Okay then. This is a square wave, always remember. Right? And then second one is what? Attenuated square wave. What is the meaning of attenuated square wave? You will get the output like this. This is called attenuated square wave. Right? This is the output. It is a V set. It is what? Vt. It is a minus V set. And this is what? Minus Vt. Now what about the third waveform? Third waveform is a triangular wave. How to write the triangular wave? The capacitor will charge, right? Capacitor will charge from minus Vt to plus Vt. This is the minus Vt to plus Vt. and then from my plus Vt to minus Vt. And that is the diagram. This is the voltage across what? Capacitor. This is the voltage at non-inverting terminal. This is the voltage at output. In a one diagram, all the three diagrams. Okay. And then this is called what? T1. This is called T2. So what is the time period of the signal? T1 plus T2. T1 plus T2. T1 plus T2. T1 plus T2. And this is called 2RC log of 1 plus 2R2 by R1. This is the formula. This is the formula. This is, if it is according to my formula, it is the R1, it is the R2. If suppose it is using here R2 and R1, then R1 by R2. You have to simply change the formula. 2 times of R1 by R2. Always remember first this and then one. R1 by R2. This resistor and RC. So this is the formula. 2RC log of 2R2 by R1. That is the formula for T. What is the formula for the frequency? 1 by T. And they will ask direct question. What is the frequency of the output? Right? Attenuation means amplitude may decreases most of the case. Yes. Triangular wave generator. Yes, last one. This is a square wave generator. That is what relaxation oscillator. Again, we are using the different types of diode D1, D2, D3 and what? D4. This is a standard diagram for relaxation oscillator. In this case, we are getting the different time constant. For charging, we are getting the different time constant. For discharging, we are getting the different time constant. Right? And that is a very simple same diagram. The diagram output will remain same, but the output plus Vset and minus Vset will remain same, but the Vt will change and the timing will change. Time constant will change. This is called relaxation oscillator. Always remember output is equal to plus Vset. If always remember there is a positive feedback. Positive feedback is dominant. Output has two levels, plus Vset and minus Vset. If it is plus Vset, diode D1 and D4 on. D4 on. D3 and D2 off. Then capacitor will charge through this path. Then the time constant will be R1C. Time constant will be R1C. And what is the threshold voltage? This diode is on. And that's why the threshold voltage is given by Vt1 is equal to 10 divided by 10 plus 10 into what? Vset. That is Vset by 2. Always remember this value. 10 divided, it is out because this diode is off. In a second case, when V0 is equal to minus Vset, always remember D1 and D4 off, D3 and D2 on. Then what will be the time constant through this path? The time constant of the circuit is R2C. This is called C dash. And the threshold voltage is called Vt2 is equal to minus 10 divided by 2 plus 10 into Vset. Why minus? Because the output is negative. Minus Vset. This is what? Plus Vset. There are two methods to solve the threshold voltage and to solve this time constant. And everything is very simple. Everything is very simple. You have to use, in case of relaxation oscillator, you have to use, this is what? Vt1. And this is what? Vt2. Now, everything will remain same. And the time constant of charging will change. Now the time constant is R1C and R2C. This is the R1C and R2C. R1C and R2C because of this diode. And that's why the time period T is equal to what? T1 plus T2. Now this time these two are not symmetrical. This is what? R1C log of. Right? And we are getting the different formula for this. Right? Always remember. Okay? Then you can verify it. This is the T1. Right? Now the threshold voltage is different and that's why we are getting the different. You have to derive this formula. And no, we are not having the general formula for this. We are not having the general formula. We have to derive the formula. You have to derive the formula. Okay. Okay, this is all about what? Relaxation oscillator. So if you want to understand this diagram, then please attend my session on what Gradeup app, on complete session on relaxation oscillator, one session. In 1 hour we will derive the formula, I will give you the shortcut. Okay, last one. Yes, it is called non-linear application of what? Non-linear application of operational amplifier. Right. Now, monostable multivibrator, one state is what? 0, one state is what? 1, one state is what? 0. This is the complete diagram. One state is stable, from 0 to 1 it requires trigger, from 1 to 0 no trigger, and that's why it is called monostable multivibrator. One state is stable, one state is quasi-stable. Second, it is also called univibrator, it is also called one shot. What are the applications? It is used as delay element, it is used as, what is the comments blank, sir? मैं Satyam Roy from, okay Satyam, how are you? 3 not gate रहे series पे, then square wave होगा ना, 3 not gate रहे series, yes, astable multivibrator. In a feedback loop, not in a gate here. This is the astable multivibrator, square wave generator, multivibrator. If we are having the odd number of gate, always square wave, multivibrator, astable multivibrator, 1, 3, 5, 7 and so on. Astable multivibrator or square wave generator. If we are using the 2, then it is a bistable multivibrator. Okay? Yes, your question is right. Now, monostable multivibrator, one state is stable, one is quasi-stable. It is used as what? Delay element. It is used as pulse stretcher circuit. MSQ. They will ask MSQ on this diagram. So this is everything about that. Right now, here we are using one diode in parallel to what? C. This is parallel to C. We are using the diode. There will be a positive feedback. When we are removing this diode, it will become a stable multivibrator. When we are connecting a diode parallel to C, then it will become a monostable multivibrator. Right? This is the diagram. R, C, and we are putting a diode in parallel to that. Always remember, during a stable state, it will be Vset. Because of this Vset, this diode is on, the capacitor will not charge and circuit will remain in stable state. When we are giving the trigger, the output will switch from plus Vset to minus Vset. After some time, automatically it will switch from minus Vset to what? Plus Vset. And that's why plus Vset is a stable state, minus Vset is what? Quasi-stable state. Always remember, this is Ajay Kumar. It is 1.69 RC is the answer for what? In a standard diagram. It is not it is a waveform. Right? Now, this is the pulse. Plus Vset, and then it will go for minus Vset. This is called pulse width T. So what is the pulse width TP here? Just I am giving you the formula. TP is equal to RC log of 1 plus R2 by R1. Right, and that will be the diagram. Always remember the standard diagram, otherwise you will make silly mistake. This is R1, this is R2. Right, here we are using the capacitor, here we are using the diode. This is connected, this is R. And this is called positive feedback. Right? Now, this is R, this is C, R2 by R1 plus R2. 1 plus R2 by R1. If R2 is equal to R1, if R2 is equal to R1, then the TP is become 0.69 RC. If R2 is equal to what? 2 times of R1, then it is become log 3. Log 3 is 1.1 RC. TP is equal to 1.1 RC. 1.1 RC. Okay? It is not 1.69 RC. It is not a right answer, Ajay. Okay. This is called pulse width, 0.69 RC, or if it is R2 is equal to 2 times of R1, 1.1 RC. We have to calculate there is a number of methods. We have to calculate the VT, then the capacitor will charge up to that point. If we are increasing the R2, the voltage at this point will increase. It will take more time, and that is the concept. It will increase directly proportional to that R2. Right, this is about monostable, more than sufficient. Direct question, what is the name of the diagram? This is the diagram. What is the output during stable state? Plus Vset. What is the output during quasi-stable state? Minus Vset. What is the formula for TP? That is the formula. If value is given, you can find the value. If we are changing the polarity of the diode, the stable state will become minus Vset, quasi-stable will become plus Vset. During stable state, diode is forward biased. Okay. Last one, triangular wave generator. This is a triangular wave generator. This is an integrator. RCR. This is simply what integrator. And then one student is asking me, what is the schedule? So that is the schedule. Here we will deal with what? Relaxation oscillator. Everything about the relaxation oscillator. Then 5 different types of what? Symmetry trigger. So please go through the formula. If you want the detailed knowledge, then please join our classes on Gradeup app. Timing, date, everything is mentioned here. You can take the screenshot of this. Okay. Then waveform generator, 5 different types of symmetry trigger, silent key filter, integrator, differentiator, tricky questions on differential amplifier, clipper, clamper, rectifier and filter, and so on. Then what is the last point? Triangular wave generator. Just I am giving you the one diagram for triangular wave generator. This is a standard diagram for triangular wave generator. Right, this is the output. It is connected to the another circuit. This is the integrator. Here normally one DC is connected, variable DC. This is the R3, this is the C, this is the feedback, right? Always remember this point. This is again variable DC is connected here, VA, R1, R2, and this point is connected to this one. And this is called what? Triangular wave generator, right? Normally this variable DC is represented by this type of shape. This is nothing but variable DC, symbol for variable DC by using what? Potentiometer. Okay, and that is the shape of triangular wave generator. Always remember, this is what? Square wave generator. Here we are getting the square wave. Here we are getting the triangular wave. Square wave and what? Triangular wave. And that's why it's also called multi-function generator. Multi-function generator. Okay. This Vs is used to control the slope of the triangular wave, and this Va is used to control the amplitude of the triangular wave. Slope means what? If we are drawing the triangular wave, this type of triangular wave, this is called triangular wave. Increasing slope, decreasing slope, increasing slope, decreasing slope. This is called upper amplitude and this is called lower amplitude. By varying the value of Va, we can change the value of what? Upper amplitude and lower amplitude. If Va is equal to 0, always remember the upper amplitude magnitude is equal to what? Lower amplitude. Means if it is 5, then it will be minus 5. But Va is equal to 0. Normally in question Va is equal to 0. If Vs is equal to 0, then the rise time is exactly equal to fall time. Symmetrical triangular wave. This time is called rise time, this time is called fall time. Symmetrical triangular wave. Okay, my dear students, everything is clear to you? Up to this point, everyone please give me the feedback. Right? Then time period, always remember 4 times of R2, R3, C divided by R1. For symmetrical square wave, F is equal to 1 by T. That is the case, normal case. If Va is equal to 0, Vs 0, that is the total time period 4 R2, R3, C by R1. Where is the R2 and R3? Always remember, this is the R1, that is the R2, this is the R3. R1, R2 and R3, and that is the C. This is called timing elements. This is the time period of a triangular wave generator. Okay. So from my side it is over, and now the time is over because it is already on 1:15. In the next class 9:30 to 11, remaining part of that analog. 9:30 to 11:30 p.m. today. Tomorrow, just I am giving you the schedule. Please note the schedule. 9:30 to 11:30 p.m. analog part 2 conclusion. Right? Tomorrow 2 to 4 p.m. on new channel Gradeup EC&E Impulse. Gradeup ECE Impulse. It is on old channel, that is the Gradeup Gate. On same channel, Gradeup Gate. Then again, the remaining part of what analog, some important topics on analog. That is what Maha Marathon session, Maha Revision, Maha Marathon. You can suggest me, and if you are required any point, then Maha Marathon session. Again, 2 to 4 p.m. Then tomorrow at 9:30, Menti quiz. At the same channel, Menti quiz. Tomorrow. Menti quiz. तो join this Menti quiz. Okay then. Till then, देखते हैं जरा. अब ये हो गया आपकी पूरी क्लास. So you can download the Gradeup app now. You can subscribe Gradeup Super if you are focusing on Engineering Services Exam 2021. That is the pre in July and mains in what? October. Then you can subscribe for Gradeup Super systematic course. Unlimited access to all the structure live courses and mock tests. Download the Gradeup app for my classes. Follow me. That is Sanjay Rathi, and you will get the idea about all these classes. Tomorrow 4 p.m. no network. Yes. Today we are having the network class. Today and tomorrow. Today there is a one important session. That is simply what? Today 4 to 5 p.m. Power triangle. No change in the schedule of this power triangle. If you want to know everything about the power triangle, then you can attend. Power triangle, reactive power, average power, effective power, apparent power, everything about the power triangle at 4 p.m. today. And that is continue. That class will continue. Okay then, thank you for attending the class. And then, good day and good luck. Thank you.